Hey there, guys. Welcome to our most recent lecture on the connective tissues. Today, we are going to learn all about cartilage, bone, and blood, and wrap up the connective tissues. So, first things first, let's go ahead and get started on a warm up. So, take a look at these questions, and it's just asking you to name the tissue. This is from last class that would fit the description or the function. So, go ahead, think about these for a second, pause the video, and when you unpause, I'll give you the answers. All right, so let's go ahead and get through this. So the tissue that acts like skin glue, the best answer for this would be areolar connective tissue. Okay, and if you remember, areolar connective tissue was a loose connective tissue. It was very vascular, and it is subcutaneous. In other words, underneath the skin. Great. Which tissue is strongest in a single direction? This would be dense, regular connective tissue. And if you remember, that's the one where all the collagen fibers are all lined up, so it's very strong in one single direction. Okay, the third one acts as a filter. Okay, so whenever we're seeing like a filter, we're going to think about like something that's shaped like a net, and in this case, it is going to be reticular tissue. Okay, and that has those reticular fibers that kind of form like a little like sieve or like a net. Okay, next one is strong in all directions. This is going to be dense, irregular connective tissue. And if you remember, this is the one that had collagen fibers, but those collagen fibers ran in every single direction, and they're very dense, so it's very strong, but it's strong in all directions. Unlike the dense regular, which is a regular pattern, but strong in one direction. Okay, stores energy. This is adipose connective tissue, which, if you remember, had a bunch of adipocytes. And those adipocytes store triglycerides. And then is strong in all directions and stretchy. This is going to be our elastic, also known as dense elastic connective tissue. And that was the one that had collagen running in different directions, but also had these elastin fibers, so that it was strong and stretchy. And that was something that you would find in your arteries, and this would be found in your like bronchi, bronchioles. So in other words, it's in your airways too to help you stretch when you breathe. Great. All right. So moving on to new material. Today we're going to turn our focus to cartilage. And cartilage is interesting. It's a very strong and flexible tissue, but it's really defined by the fact that it has a gel matrix. So that's the main thing we're seeing here, this gel. And so that's kind of what makes cartilage different from other things. This gel is kind of tough, but also flexible. So it's kind of like a hybrid. It's not as just like hard and tough as like a dense connective tissue, but it's also not as like loose as a loose connective tissue, but it has a lot of strength. And so these are avascular and non-innervated tissues, which make them kind of weird. Okay, the first one is called hyaline, and hyaline is the most basic of all of our cartilage. And so in hyaline, we will see some cells. And these particular cells are chondrocytes. And those chondrocytes spend their whole life producing the matrix, which is this gel. And this gel contains a lot of protein. So basically, the protein produced by these chondrocytes goes out and kind of fills up the space and gives us gelatinous matrix. And so hyaline is just a plain gel matrix. It's the most common and basic cartilage in your body. Hyaline you find on the end of all your bones. So it's found in your joints, it's found in your nose, and it's found on your ribs. So like that little rib cartilage is all made of hyaline. So like I said, it's the most common. Now, let's say we want to take hyaline, and let's say hyaline wasn't getting it done for us. we could use fibrocartilage. So fibrocartilage looks pretty much the same. We still have those same chondrocytes. And we still have the gel, but now we add in collagen fibers. And we know collagen is very strong. So this is gel plus collagen. And this is the strongest. And we find fibrocartilage in the meniscus of the knee. This is your intervertebral discs. Which is in between your the bones of your spine. And we also find this in this area called the pubic symphysis, which is located in between the pubic bones. So it's in like the hip bone area. And so basically, if you look at this, in the middle of your knee, the meniscus, in between your vertebrae, and in between your hip bones, these are areas that are under a lot of pressure. So they need a lot of strength. So we add this collagen fiber in here to reinforce it and make it stronger. So it's basically hyaline plus collagen. Now, elastic, I'm sure you can imagine, this is going to be gel plus elastin. And this is what it looks like. So elastic cartilage, same thing. Still have chondrocytes, still have gel, but now we're adding these kind of wavy elastin proteins. And of course, that's going to make it stretchy. And so, elastic cartilage is found in two places. This place called the epiglottis and your ears. So the external ear, this is going to be an ear, just pretend. This part that's like, the outside part of your ear that sticks out, you can like bend it, but it's also kind of somewhat rigid. That is made of elastic cartilage. So it's very stretchy and flexible. The epiglottis is located in your throat. And so when you swallow, right behind your tongue, you basically have this little area down here where one tube goes down to your stomach, and that's your esophagus. Another tube goes down into your larynx. And there's like a little flap right here that when you swallow comes down and covers up the larynx so that the food goes down to your esophagus. And that little flap is called the epiglottis. And so literally, if you were to look at the larynx as your voice box, it's got this one little thing that sticks out of the top, kind of looks like a leaf, and that's hollow, goes down, it's a hollow tube. And this little part can bend forward and just kind of cover it up, and then it can flip back. And so what elastic cartilage is really good at doing is it's good at being pretty rigid and strong because it's got this gel matrix, but then it's also very flexible, so it can flip-flop back and forth. So just like you can bend and twist your ear all day and it doesn't do anything, it doesn't hurt you, same thing happens with the epiglottis. Every time you swallow, it has to flop down, cover up the glottis, or the top of the larynx, and then flip back. All right, so let's take a look and see what these look like. So here is a look at hyaline cartilage. We are actually looking at a fetal skeleton. So your skeleton, when you were a fetus, was completely made of hyaline. And you can see there's our chondrocyte right there. And you can see there's another one over here. And in between is all this gel matrix. And so that's what they're showing here. Each one of these chondrocytes lives in a little tiny hole inside of the gel matrix called a lacuna. And they just kind of produce this stuff. They produce this ground substance that's containing a lot of protein. Here's another picture of some hyaline. And you can see all this kind of purple stained stuff. That's the gel matrix. Oh, by the way, and so remember how we said the fetal skeleton was originally made out of hyaline. So as your bones grow, your bones actually grow inside of this hyaline cartilage. And that's why the ends of all your bones are covered in hyaline. So once upon a time, like your bones looked like this, and they were just all cartilage. And then over time, what happened was the bone started to grow from the center out, and then there's little end caps that start to grow. And so at one point, when you were born, you had all this bone, but in between was still hyaline. And at the very end of the bone was also hyaline. And this is your growth plate right here in between. And then as you grew up, your bones grew out long ways, and these caps grew back in, and eventually they all fused together, but you still have hyaline at the end of the bone. And that is what pads your joints. So like I said, hyaline is the most common cartilage in the body. There's fiber cartilage. This happens to be in your knee that we're looking at here. And you can see all these collagen fibers reinforcing and making it a lot stronger than it normally be. This happens to be the tendon of the quadriceps femoris muscle, is what we're looking at here, which contains some fiber cartilage. And here's another picture, and you can just see all the collagen fibers lined up. And then the last one is elastic cartilage. And so now we're looking at the auricle, which is the external part of your ear. And you can see that it also has a whole bunch of fibers, but this time they're elastin, and that gives it its elasticity. And there's another picture of what it looks like, and you can see there's a bunch of fibers in here. Okay, the last couple of tissues we have to talk about are osseous tissue and blood. Osseous tissue, anytime you see the prefix OSS, os, like osteoporosis, is going to refer to bone. In fact, OS is the Latin word for bone. So anytime you see anything that starts with OS, OSS, OSTEO, so os or osteo, is going to be related to bone somehow. Osseous tissue is interesting. When you look at this, you will see a central blood vessel, and then around that are a whole bunch of cells known as osteocytes. And those osteocytes kind of form a set of rings around this blood vessel. And they're embedded inside of this solid matrix. And so you actually see there's like a little ring here, and there's like another ring outside, and then actually you'll see more osteocytes out here, and they're also forming a ring because these bones actually grow from the inside out. And so when we see these, all these cells are trapped into these rings in this solid mineral and protein matrix. And guess which protein we stick inside of our bones to make them strong? You guessed it, collagen. Okay, so the key of osseous tissue is that they have a solid matrix. It's the only tissue that's a completely solid matrix, not a gel, not a bunch of protein, but actually solid. It's actually made of minerals. Great. Blood, on the other hand, is the only tissue that has a completely liquid matrix. And so when we look at blood tissue, we see little red blood cells, little divots, that's why I put this little sign in them. And we see some macrophages, those little blobs, and other white blood cells. And we see some platelets, which are just like little pieces of cell. And then all around them is just plasma, no protein fibers. And the reason for this is that we don't want to have blood clots. So in normal blood circulating around your body, there's no fibers at all. Now, when blood escapes out of your body, like when you get a cut, it actually, the platelets start to form some fibers, and that's how you get like a scab or a blood clot. But basically, the plasma is the liquid part. Now, when it's in a lymphatic vessel, it would be called lymph, but lymph or plasma or interstitial fluid, I could have put that in there too. But the cells that we see red blood cells, which are these little guys, white blood cells, which would be like a macrophage, and then these little tiny guys down here are platelets, which are the clotting cells. All right, let's take a look and see what these look like. So here's your osseous tissue. Hey, look, I did a pretty good job with my drawing. Look, there's the picture. There's my drawing. Not bad, right? But you can actually see this is the capillary right here in the center. So this is your little blood vessel. And then there's all these osteocytes forming a ring around it. And then you can just see how they just form all these different rings, kind of like a tree trunk. And it's because the bone grows from the inside out. And just like a tree grows, it forms different layer upon layer upon layer as it grows. Inside of all these little holes, there's the cell. So there's the osteocyte actually living inside, and it's trapped inside the bone, which is pretty crazy. And they're just basically hanging out there, maintaining your bone, keeping your bones healthy. And here's another picture. You can see it once again. You can actually see the concentric circles. Here is some blood tissue. And in this picture, you can see There's red blood cells. There's another red blood cell. In fact, it's almost all red blood cells. Here's a white blood cell. And this little guy right here, this little tiny thing is a platelet. And those are what we call the formed elements of blood. In between all this white space, this is the plasma. So it's just like that kind of semi-clear fluid in between. And you can see here's another great picture. You can see lots of plasma, so just lots of liquid, lots of red blood cells. Here's a white, here's a red. And then these little tiny things down here, that'd be a platelet. And you can see like, here's a little platelet, here's a little platelet, but mostly it's red blood cells. No fibers. That's the key. All right, so let's take a little review of connective tissue. The main thing to know about connective tissue is the matrix defines it. So there's lots of matrix, and the matrix determines the function of the tissue. So if I tell you that there's a tissue that has a gel matrix, you know it's going to be cartilage. And that cartilage, that gel is going to make it kind of like have support, but also be flexible. If I told you a tissue has a solid mineral matrix, you know it has to be osseous, so it's defined by its matrix, and you know it's going to be hard and give support because it is solid minerals. If I told you it was a liquid only with no protein fibers, you would say it's blood. And that liquid defines blood, right? Blood is defined as a liquid tissue, and it flows around very freely. If I told you that I had a whole bunch of collagen protein fibers all lined up, it's dense regular. So the matrix determines the function. This is going to be strong in one direction, okay? So this is very key. This is probably the most important point. The cells, their job is to make that matrix. So all those different 6 cell types we talked about, they're basically supporting this. You know, the chondrocytes are creating the gel. The fibroblasts are making the fibers. The osteocytes are making the solid mineral matrix. So basically the cells are in charge of making that matrix happen. Connective tissue is very diverse, very different. Everything, like we said, from blood to tendons to cartilage to bone, all sorts of weird stuff. And then we can break all this down into the 5 categories. So there's loose connective tissues where the fibers are kind of loosely arranged, dense, where they're more densely compacted, cartilage, where we see the gel, osseous, where we see mineral, and blood, where it's just liquid. Okay, so no fibers, minerals, gel, lots of fibers, few fibers. And that's it. And if you know those, if you can do all that, you're good. That's all connective tissues are. So ladies and gentlemen, that's it. I hope you enjoyed all of this. And if you have any questions, hit me up. And we'll be reviewing this week and getting ready to take a quiz a little bit later. See you later.